Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is special matrices. We all know the definition of a matrices, a rectangular arrangement of n numbers in m rows and n columns and enclosed within a bracket that is called a matrix. And a matrix is just not a collection of elements, but every element has assigned a definite position in a particular row and column. We all know the types of fundamental matrices like square matrix, diagonal matrix, identity matrix, upper triangular matrix, lower triangular matrix, symmetric matrix, and zero matrix, row matrix, and column matrix. I have made a video on the types of matrices. You can refer that video in case if you want detailed information about the fundamental types of matrices. Here in this video we are going to discuss the special type of matrices. Matrices have numerous applications both in mathematics and other sciences. We will list the matrices which have application in the field of mathematics. The matrices are given in alphabetical order with special matrices under each category if applicable. The first special type of matrices is alternate matrix. An alternate matrix is a matrix with a particular structure in which successive columns have a particular function applied to their entries. Examples of alternate matrices include Van der Waals matrices and Moore matrices. I'll give you that form. Alternate matrices are used in coding theory in the construction of alternate codes. You will not get this alternate matrix in calculation. It will be used only in coding. Let's see what is the meaning of Van der Waals matrix and Moore matrix. A Van der Waals matrix is of the order n and it is of this form. This is also called an alternate matrix. Sometimes the transpose of an alternate matrix is known as the Van der Waals matrix. This will be used in Lagrange interpolating polynomials and polynomial least square fitting that you will be learning in your future classes. Now let's see what is the meaning of Moore matrix. It is a matrix defined over a finite field. So this information is enough about these two. Here is the next special type of matrix. The name is called anti-diagonal matrix. Anti-diagonal is the diagonal of a matrix starting from the lower left corner to the upper right corner of the matrix. An anti-diagonal matrix is a matrix where all the entries are 0 except the anti-diagonal. Anti-diagonal means it will start from the left corner to right upper corner. And I have written an example. You can notice that only this diagonal will be some numbers other than 0 and all these other entries are 0. This is called anti-diagonal matrix. Diagonal matrix will be in this form. It will start from the left top to right bottom. So you should know the difference between diagonal matrix and anti-diagonal matrix. Now the third special type of matrix is arrowhead matrix. An arrowheaded matrix is a square matrix which has all zeros in all entries except the first row, first column and the main diagonal. So if you draw a line here, it will look like an arrow. So I'll repeat again. An arrow-headed matrix is a square matrix which has zeros in all the entries except the first row, first column and the main diagonal. This is the general form of the arrow-headed matrix. Real symmetric arrow-headed matrix are used in some algorithms for finding the eigenvalues and eigenvectors. Arrow-headed matrices are important for the computation of eigenvalues by dividing and conquer approaches. Here is the next type, band matrix. A band matrix is a sparse matrix whose non-zero entries are confined to a diagonal band comprising the main diagonal and 0 or more diagonals on either side. The main diagonal and on either side. This is the general form of a band matrix. A matrix is called a band matrix or banded matrix if its bandwidth is reasonably small. Now let's see the other type, symmetric and skew symmetric matrix. This would be symmetric. Hope you understand the difference between symmetric and skew symmetric. Let me show you an example for both symmetric as well as skew symmetric matrix. Here is the example for symmetric matrix. Did you notice that the numbers are different in the diagonal, but these numbers are reflections of the other one, HH, GG, FF. So this type of matrix is called symmetric. Now let's see an example for skew symmetric. The diagonals will be 0 and these values will be the reflection of the other but with a negative sign, because Aij is equal to minus of Aji. And the difference between the symmetric and skew symmetric is, in the skew symmetric the diagonal will be completely 0. Hope you understand the difference between these two. Now let's see what is meant by singular and non-singular matrix. Any square matrix A is said to be non-singular if the determinant is not equal to 0. Same way, a square matrix A is said to be singular if the determinant is equal to 0. Here this A is denoted by determinant of A. It means corresponding determinant of a square matrix. Let me write an example. Here is an example. Consider this matrix A. If I find the determinant of this matrix, 2 times 5 is 10 minus 4 times 3 is 12. If you subtract these two, you'll get a number other than a 0, which is not equal to 0. Then this is an example for non-singular matrix. Let me show you an example for singular matrix. Please consider this matrix. A is 5 to 10, 4. Let's find the determinant of this one. 5, 4 is 20. 10 times 2 is also 20. If you subtract these two, you'll get a 0. So this matrix is a singular matrix. Do you understand the difference between singular and non-singular? Okay, cool. Now let's move on to the next type, unitary matrix. A square matrix is said to be unitary if A, the transpose of the bar A equal to I. Since, I'll write it on the board. The transpose of A dash, the determinant of transpose of A dash will be equal to determinant of A. And if you multiply it by A, you can just split it into 2. This A transpose of dash times A. Therefore, that's the proof for the unitary matrix. The determinant of unitary matrix is of the unit modulus. For a matrix to be unitary, it must be non-singular. Okay, now let's move on to the next type, orthogonal matrix. A square real matrix with orthonormal columns is called orthogonal matrix. Or you can just say any square matrix A of the order n is said to be orthogonal if this condition satisfies. Okay, now let's move on to the next type of matrix, idempotent matrix. A square matrix A is called idempotent matrix provided it satisfies this relation, A square is equal to A. I'll show you an example. Let me take a matrix, a square matrix A. Please consider this matrix A. This is going to be an idempotent. I'll show you how. Now let's find what is A square. A square is nothing but A times A. You have to multiply A by itself. Am I right? Now let's multiply this matrix with this matrix. You have to, hope you know the matrix multiplication. You have to multiply this row with this column and row, column, ray column. And you have to multiply in the same way for each and every row and column. So if I do the calculation, I'm getting again the A itself. Let me show the step for the first row and first column alone. I'm getting again 2, which is the first number, A11 in the original determinant, original matrix A. Same way, if you proceed with all the other steps, you'll get the same values back. So if you square the matrix, you should get back the original matrix itself. If this is the case, we can say that the square matrix A is an idempotent matrix. Hope you are clear with this type of matrix. Now let's move on to the next type. The next type is involuntary matrix. A square matrix A is said to be involuntary if A square is equal to I, the identity matrix. Now the next type, nil-potent matrix. A square matrix A is called a nil-potent matrix if there exists a positive integer m and such that A raised to m is equal to this, which is nothing but the null matrix. If m is the least positive integer such that A raised to m is equal to 0, or you can say it as null matrix, then m is called the index of the nil-potent matrix A. So if this condition satisfies, the matrix is called nil-potent matrix, where this is called the null matrix and this one is the index of the nil-potent matrix A. Hope you are clear with this type. Here in this video I have covered all possible special type of matrices that are applicable in your class. There are also many other types of matrix which will be applicable in the higher level of education. For example, binary matrix, adjacency matrix, design matrix, incident matrix, permutation matrix, exchange matrix. There are so many types like this, like bisymmetric matrix, centrosymmetric matrix, block matrix, persymmetric matrix. So all these are applicable only in the higher level of classes. So I think these types are enough for you. You can have a glance over all the types. In case if you get any query, please let me know. See you in the next video. Have a great time ahead.